In the previous lecture, we discussed the electrophysiology of the heart. In this lecture, we are going to build off that concept and discuss how those electrical impulses impact what we see on the EKG. Think of each myocyte giving off its own unique electrical impulse, each impulse varying in intensity and direction. It is the sum of these electrical impulses, or vectors, that give us what we see on the EKG. Let's begin by discussing vectors, which represent the electrical impulse. Therefore, each vector, or electrical impulse, created by myocytes will represent an amount of energy and the direction in which that energy is directed. So vectors have energy and direction. Vectors add up when they go in the same direction and cancel each other out if they point in opposite directions. If the vectors are at an angle to each other, they will either add or subtract energy and change direction when they come together. This forms a resultant vector. Let's try some quick, simple examples. So if we have a vector going in this direction and we label, say that has 3 as our energy, and the amount of energy of this vector is also 3, but in the opposite direction, the resultant of this vector is 0 as they cancel each other out. Now, if we have a vector going in the same direction as each other with the same amount of energy, these will combine and make an even greater, double the length of that vector and be 6 as its total energy. And we also said now if we have a vectors going in different direction of each other, so one going this way and the other going this way, they will combine to give a resultant vector that goes in about this direction, and the resultant energy will be greater than 3. So it seems quite easy, if you look at these vectors, the ones going in opposite direction you subtract, so 3 minus 3 is 0, and those going in the same direction you simply add, so 3 plus 3 is 6. Now this is a very basic level of understanding of vectors, but really all you need at this point. Hopefully some of this makes intuitive sense. Now that we have a basic understanding of vectors, this will allow us to understand the normal electrical axis of the heart. So let's take a look at this image. Notice how we have so many various vectors, all going in different directions. Eventually, if you add all these vectors up, you'll have the normal axis of the heart, and as you can notice, this is the resultant axis. So it's downward pointed to the left of the patient. So this being the left side of the patient and this being the right. Now similarly to this electrical axis that we have here coming down, each wave and segment of the heart represents a vector. In other words, we will see a P wave vector, a QRS vector, an ST segment vector, and a T wave vector. Therefore, we can say that the EKG is simply a measurement of these vectors as they pass an electrode or a lead. So what are these electrodes or leads that we are talking about? Imagine these electrodes as sensing devices that pick up any electrical activity that occurs underneath them. Let's start by taking a look at this image on the left. When a positive electrical impulse moves away from an electrode, so coming from here, going towards the positive, so this being the positive end, it results in a downward or negatively deflected wave. Note the wave in A here, how it is deflected downward in a negative direction. So as this wave is moving away, you can see this is deflected downward in a negative direction because it's moving away from the electrode. However, when a positive electrical impulse moves toward an electrode, it results in an upward or positively deflected wave. And here we see this in C, how it is deflected upward in a positive direction. So we said this is moving away from this electrode here in A, so it'll be negative, but it's moving towards this electrode over here, making it deflect upward and become positive. Finally, when the electrode is somewhere in the middle or perpendicular to the electrical impulse, the part of the electrical impulse going towards it will be positive and then become negative as it goes away from it. And that's what's going on here in B. So notice this electrode is perpendicular to this electrical impulse. So what's happening as this is coming towards this electrode right here, it deflects upward and becomes positive. But as it travels away from this electrode here, it deflects negative. So what we have here is the leads, or the electrodes, that pick up the electrical activity of these vectors, and the EKG machine converts the vectors into waves. So let's say that one more time. We have these electrodes here that are picking up these vectors of electrical impulse, and they're converting it into a wave that we'll see on the EKG. If we now move to the image over here on the right, imagine that we have electrodes all around the heart, meaning that each one of these, each one going around, is an electrode. And this allows us to get a different picture of each angle of the heart. It provides a three-dimensional picture of the heart's electrical axis and is exactly what the EKG is meant to give us. So if we think of each of these electrodes here as the heart, and we consider this the right side of the heart and this the left side, this camera will give us a better image of the right side of the heart, and this a better picture of the left side of the heart. Whereas this camera may give us a better picture of the inferior part of the heart. We aren't going to get into where to place the leads on a patient in this lecture, but we will discuss the two lead systems briefly. So there are two lead systems, the hexaaxial, or the limb leads, and the precordial system, or the precordial leads. The hexaxial system is a coronal cut that consists of 6 limb leads: 1, 2, 3, AVR, AVL, and AVF. The positive end of the lead gets the lead name. So we said hexaxial, meaning that there are 6 limb leads, right? And these 6 limb leads are 1, 2, lead 3, lead AVR, lead AVF, and lead AVL. So this image here on the left, where you have the lead, so lead 3 here, lead 1, and lead 2, imagine them coming to the center of the heart, right here in this image, and that's simply these same leads. And we noted that the positive end of the lead gets the name. In other words, this positive end gets lead 1, so the negative side would be here. This lead 2 is the positive end, and this would be the negative end of lead 2. The negative end of lead 3 would be here, and its positive end down here. And this is also true for leads AVR, AVL, and AVF. Now look at the image on the right and note that each lead is 30 degrees apart. If you can imagine a circle consisting of 360 degrees and divide that by 6 for the 6 limb leads that we're discussing, this puts 30 degrees between each other. And also note how the center of each lead system sits at the center of the heart. So here we have the center of the heart, and all lead systems are sitting. So again, going this way would be lead 1, coming down here to its positive electrode, we have lead 2, and starting up at the top here and coming down, we have lead 3 coming to its positive end. And we also mentioned that the distance, or the degrees between, for instance, this lead 2, its negative end, and AVR, its positive end, is 30 degrees. And that is the same between each one of these. The second lead system is the precordial system, which is a sagittal cut that consists of the 6 precordial leads. These leads are perpendicular to the limb leads we just discussed. So the precordial system, or the precordial leads, consists of leads V1 through V6. And as you can see, all of these sit right on top of the chest. So again, think of these leads or electrodes as cameras looking at different aspects of the heart. So if we look at V1 and V2 here, they're looking at the anterior of the heart, which gives us a great view of the right ventricle. So it would be the V1 and V2 leads that we would go to get the best idea of what's going on in that area. Now if we looked at the lateral leads, this would be best looked at with V5 and V6 in these leads. Again, in this middle picture, we have V1 and V2 giving us a great anterior view of the heart, and V5 and V6 of the precordial leads giving a great view of the lateral side of the heart. Here again in this last picture, here we have the right ventricle and left ventricle placed in the center, and again V1 and V2 giving us a great view, great cameras of the right ventricle. And again here we have the lateral leads V5 and V6 looking at the lateral wall of the heart. Now let's combine the limb and precordial leads. So where do you think the EKG would show changes if you had a problem in the inferior part of the heart? Well, let's look at where's the inferior part of the heart, down here. And what leads are there? Well, we have 3 AVF and 2. So 2, 3, and AVF look at the inferior aspect of the heart. So certain changes in these leads could point to an inferior wall MI. So what about the leads V1 and V2? Well, these leads here, we just previously discussed, they run along the septum. And thus changes in these leads may indicate a septal wall MI here, if there's a problem that you see or changes you see in the EKG. Now what if you have changes in leads 1, AVL, and then V3, V4, V5, and V6? Well, let's look at this. V3 and V4, so these two here, make up most of the anterior leads, right? And leads 1, AVL, V5, and V6, so we said these ones here, make up the lateral leads of the heart. So these are the lateral leads. Therefore, ischemic changes on the EKG may indicate an anterolateral MI. So meaning that if potentially we see ST elevation in V3, V4, V5, V6, as well as in AVL and lead 1, this may be an anterolateral MI. And we'll get into these specifics later as we get into looking at EKGs and pathology that may arise. Okay, so let's just review this one more time. Let's say we have the leads here, and then the region of the heart that's affected, or that lead indicates best. So if we look at leads 2, 3, and AVF, we said these are the inferior leads, right? We said V1 and V2 will be the septal leads. We said that V3 and V4 help us looking at the anterior aspects of the heart. And then we said V5, V6, as well as 1 and AVL give us a great picture of what's going on in the lateral aspect of the heart. Okay, so that's all for this lecture. I hope you can get a sense that we are starting to get into the fun stuff. Again, understanding these introductory lectures is key to building a solid foundation for moving forward. Take a few minutes to review what we just covered and then head over to the next lecture.